Welcome back to Database Internals Crashcasts. I'm Sheila, and as always, I'm joined by my co-host, Victor. Before we dive in, we'd love to hear from you. If you're enjoying our show, please take a moment to rate us on your favorite podcast platform. It really helps us reach more database enthusiasts like you.
That's right, Sheila. Your support means the world to us. Now, let's get into today's topic. We're continuing our journey through database models, and we've arrived at a game-changer in the database world: NoSQL models.
Absolutely, Victor. But before we dive in, I've got a quiz question for our listeners. Are you ready?
I'm always ready for a good database quiz, Sheila. Bring it on.
All right, here goes. In what year was the term NoSQL first introduced, and what percentage of organizations were using NoSQL databases by 2019?
Ooh, that's a tricky one. It's testing both historical knowledge and recent adoption rates. I love how it combines the origin of NoSQL with its current impact. Our listeners will need to put on their thinking caps for this one.
Indeed. We'll reveal the answer at the end of the episode. Now, Victor, could you start by explaining what exactly NoSQL means?
Certainly, Sheila. NoSQL stands for Not Only SQL or Non-SQL. It's a broad term for database systems that differ from traditional relational database management systems in some significant ways. The key thing to remember is that NoSQL databases are designed to handle large volumes of unstructured or semi-structured data, which is increasingly common in our big data era.
That's interesting, Victor. So it's not necessarily a replacement for SQL databases, but more of an alternative or complement.
Exactly right, Sheila. NoSQL databases were developed to address some limitations of relational databases, particularly when it comes to scalability and flexibility. They're often used alongside traditional SQL databases in what we call polyglot persistence.
Polyglot persistence? That's a mouthful. Could you break that down for our listeners?
Of course. Polyglot persistence simply means using different database technologies for different parts of your application based on what fits best. It's like having a toolbox with various tools, each suited for a specific job.
That makes sense. Now, I've heard that there are different types of NoSQL databases. Could you walk us through them?
Absolutely. There are 4 main types of NoSQL databases: document stores, key value stores, column family stores, and graph databases. Each has its own strengths and use cases.
Let's start with document stores. How do they work?
Document stores, like MongoDB or CouchDB, store data in flexible JSON-like documents. Each document can have a different structure, which makes them great for applications with evolving schemas. Imagine a library where each book can have a different set of attributes. That's how flexible document stores are.
That flexibility sounds really useful. What about key value stores?
Key value stores, such as Redis or DynamoDB, are the simplest NoSQL databases. They store data as pairs of keys and values, much like a giant hash table. They're incredibly fast for read and write operations, making them perfect for caching and session management in web applications.
I see. And column family stores?
Column family stores, like Cassandra or HBase, store data in column families, which are containers for rows. They're excellent for handling large amounts of structured data across many machines. Think of them as spreadsheets with a flexible number of columns for each row.
That's an interesting analogy. Lastly, what about graph databases?
Graph databases, such as Neo4j, are designed to handle highly interconnected data. They store data in nodes and edges, making them ideal for social networks, recommendation engines, or any scenario where relationships between data points are as important as the data itself.
Wow, that's quite a variety. It seems like NoSQL databases offer a lot of flexibility. But I'm curious, what are some of the trade-offs compared to traditional relational databases?
Great question, Sheila. While NoSQL databases offer scalability and flexibility, they often sacrifice some of the ACID properties that relational databases guarantee. ACID stands for atomicity, consistency, isolation, and durability. NoSQL databases often use a model called BASE, basically available, soft state, eventually consistent.
Acid and base? It sounds like we're doing a chemistry experiment. Could you explain what those mean in practice?
Certainly. In simple terms, ACID ensures that database transactions are always in a valid state, while base accepts that the database might be in an inconsistent state at times, but will eventually become consistent. This trade-off allows NoSQL databases to achieve better performance and scalability in distributed systems.
I see. So, when would a developer choose to use a NoSQL database over a relational one?
There are several scenarios where NoSQL shines. For instance, when dealing with large volumes of unstructured or semi-structured data, when you need horizontal scalability to handle big data, or when you need flexible schemas for agile development. Social media platforms, real-time big data applications, and content management systems often leverage NoSQL databases.
That makes sense. Are there any common misconceptions about NoSQL that our listeners should be aware of?
Absolutely, Sheila. One common misconception is that NoSQL means no schema. While NoSQL databases are often schemaless, it's more accurate to say they have a flexible schema. Another misconception is that NoSQL databases can't handle transactions or maintain consistency, which isn't true for all NoSQL databases.
Those are important points to keep in mind. Now, as we're wrapping up, could you share a fun fact about NoSQL databases?
Sure thing. Here's a fun fact. The term NoSQL was actually coined by Carlo Strozzi in 1998 for his open-source relational database that didn't use SQL. Ironically, his database wasn't what we now consider NoSQL. The term was later reintroduced by Johan Oskarsson in 2009 for non-relational distributed databases.
That is ironic. And speaking of history, it's time to reveal the answer to our quiz question. Victor, would you like to do the honors?
I'd be delighted. The term NoSQL was first introduced in its current context in 2009. As for adoption, by 2019, about 68% of organizations were using NoSQL databases in some capacity, according to a survey by Flexera.
Impressive adoption rate. To wrap up, let's summarize the key points we've covered about NoSQL models. Point 1. NoSQL stands for Not Only SQL and offers alternatives to traditional relational databases. Point 2. There are 4 main types: document stores, key-value stores, column family stores, and graph databases. Point 3. NoSQL databases offer scalability and flexibility, often trading some ACD properties for base principles. Point 4. They're particularly useful for handling large volumes of unstructured data and scenarios requiring high scalability. 5. While offering many advantages, it's important to choose the right tool for the job, considering both NoSQL and SQL options.
Excellent summary, Sheila. And remember, listeners, whether you're Team SQL, Team NoSQL, or Team Use the Right Tool for the job, we'd love to hear from you. Visit crashcasts.com, join our Discord community, or support us on Patreon. Your engagement helps us create better content for database enthusiasts like you.
Absolutely, Victor. And don't forget to subscribe to the podcast and rate us on your favorite platform. Until next time, happy databasing.